Right. Can you see my slide now?
Yes,
Can, sir. Yes, sir.
Boleh Okay. Okay. So today we will finish our chapter 5 and dimensional analysis. Before this, we have covered the two subchapters, the relation between the experimental work and dimensional analysis, and also about the modeling and similitude. So today we will cover the last two subchapters about the Buckingham's pi theorem and how we can use this theorem to determine the dimensionless parameters. So these two is related lah, and we will cover this today. This done. Okay. Alright. So determination of dimensionless parameters. Okay. Previously, we have mentioned that one of the primary purpose of dimensional analysis is to generate the dimensionless parameters, or what we will call after this as pi. Okay. So dimensional parameters are combined sets of parameters which includes dimensional variables, non-dimensional variables, and dimensional constants. So we will discuss what is these three. We have seen this a lot in the any equation. Okay, the dimensional variables is a dimensional quantities that change or vary in the problem. For example, the length and time. The length or time. Ini benda yang ada dalam equation kan. For example, velocity. So you have length and time. And this can change lah. The length can change, the time pun can change kan. So that is dimensional variables. And the second one is the non-dimensional variable. So this is quantities that change or vary in the problem but have no dimension. Okay, so there that's why it's called non-dimensional. There's no dimension. For example, the angle of rotation, the theta. Okay, so there is no dimension for that. So it is it can appear in the any equation. So we will use that quantities kan, the non-dimensional variables. The last thing is the dimensional constants. This is also quite common. We see this dimensional constant is a quantities that have dimension but remains constant in the problem. For example, the G kan, the gravitational acceleration. If you want to find the W, the force downwards, mg kan, the G is always constant but it has a dimension. The dimension meters squared per second kan. So these three are the one that we have seen before, but maybe we not discuss it specifically. So what is this? What is angle? What is G? So this is that three types lah: dimensional variables, non-dimensional variables, and also dimensional constants. Okay. Any question about this?
no, sir.
Okay. Okay. So during dimensional analysis, okay, when we do the dimensional analysis, dimensionless parameters, dimensionless parameter ni, that one the one that we want to generate, kita nak generate dimensionless parameter ni, ini purpose dia, purpose of dimensional analysis. Okay, kita nak generate dimensionless parameters, and it is represented using uppercase Greek letter pi. Okay, pi is our dimensionless parameter. When we say dimensionless, so there is no dimension for that parameter. Okay, so it's no unit lah. Okay, in a general dimensional analysis problem, there is one pi that we will call the dependent pi. Okay, dependent pi, and we give it the notation as pi 1. Okay, so pi 1, this is the dependent variable. Okay, dependent variable. So it means this pi is depend on something. Okay, we will see this after this clearly. And the parameter pi 1 is in general a function of several other pi. Okay, that's why it calls dependent again. It's dependent on something, and which we will call as independent pi. Okay, and the function relationship is, so the pi1, which is the dependent variable, so this is the dependent variable, is a function of pi2, pi3, or so on so forth lah, depending on how many pi's the equation have. So this pi2, pi3, pi4, whatever, so this is the independent pi. Okay, independent pi. So this dependent variable is depend on this independent pi. Okay, so this is the relationship lah. Okay, alright. Common established dimensionless parameters pi's accounted in fluid mechanics and heat transfer are shown in appendix section. So I show to you the appendix. So these are the examples of the common established non-dimensional parameters. You have seen Archimedes number, the Darcy efficient factor. Ini yang kita belajar masa chapter 4 kan, when we want to calculate the major loss, the minor loss, we find this friction factor from the equation for lamina 64 over Reynolds number, or you find it from the Moody's chart. So this is one common example of the non-dimensional parameters or dimensionless parameter. There's no dimension for that, and you have seen before. Apa yang kat sini awak pernah jumpa? Euler number, familiar tak? Or Fourier number? Ke tak ada yang familiar kat sini?
Tak ada sir.
Tak ada. maybe you see after in the next semester, or I'm not sure. Okay.
Jacob je sir, saya kenal.
Jacob ni, kenal?
Ya, Jacob.
Okay.
Okay.
And here maybe you was familiar to you here? Mach number? Familiar tak? In aviation ni selalu gunalah Mach number. Tak?
Tak sir.
Lift coefficient, the lift, the wing side, not yet. Okay, never mind. Here maybe Reynolds number. So if you said you never heard about this, this in chapter 4 kan, when we calculate the Reynolds number. So siapa ingat lagi Reynolds number, how we can calculate that? Ada lagi ingat tak? Siapa yang ingat Reynolds number? Ini dah tulis kat sini. Lupa, tak nampak lah, dah ada sini. The rho v L over mu kan, or rho v d. Okay, so that's Reynolds number. Itu je. Rayleigh number ni awak tak familiar? Rayleigh number tak ada
Tak sir, tak ada.
And that's all lah. So these are the example lah for common established non-dimensional parameters or dimensionless parameters in fluid mechanics or heat transfer lah. You will see in the future lah, hopefully. Okay. And to generate that dimensionless parameters, okay, the most popular method is what we call as method of repeating variables and the Buckingham-Pi theorem. So this is what we're going to learn today, how to use this method to generate the dimensionless parameters. Okay. In the past year paper, if you have go through before, you will see a lot of question is asking you to they give you a problem, then ask you to generate the dimensionless parameters, okay, using this method of repeating variables and also the Buckingham-Pi theorem. Okay, alright. So this method, the method of repeating variables and the Buckingham-Pi theorem, so there are 6 steps. You need to remember there are 6 steps, okay, involved in this method when you want to generate the pi or the dimensionless parameters. Okay, so I will go through one by one and I show you example of a question so that we can see clearly lah how we can use this this method in order to solve a real question or to generate a dimensionless parameters. Okay, Alright, the first step is list the parameters in the problem and count their total number of that parameters, or we denoted as n. Okay, n will be our number of parameters lah inside the problem. For example, okay, this question, the wall shear stress tau in a boundary layer depends on the distance from the leading edge of the body. Okay, the distance x, the density rho, the dynamic viscosity mu of the fluid, and the free stream velocity v. Okay, step 1, they said list the parameters. Step 1, list the parameters in the problem and count their total number of n. So in this example, so we have the shear stress. The shear stress is a function of, it says here, the wall shear stress depends on something. So it's a function of, so a function of, we write f, function of the distance. First is distance x, second one is the density rho, the third one is the dynamic viscosity mu, and the last one is the velocity. Okay. So in the first step, when you want to count the total number of parameters, these are the parameters lah, and the tau, the distance, the density, the mu and the dynamic viscosity, and the velocity. Okay, so the n number is 5. Boleh faham? Any question about this?
Boleh sir.
Okay. So again, this is apa tau ni apa? What is tau? No, I mean it's a shear stress. So in this dimensional analysis, what we call this tau? It is a dependent variable, kan? Dependent variable, because this tau depends on the other parameters lah, the distance, the rho, the mu, and also the velocity. So these four are the independent variable. Okay, as we discussed in the previous slide, this one, okay, pi 1 equal to the function of pi 2, 3, 4 lah. Okay, alright. Okay, so that's the first step lah. So we have 5 more steps. The second one is, saya ada nak masuk. Okay, the second one is list the primary dimension, primary dimensions of each of the parameters. Let me ask you, what is the primary dimension? If you remember the first class, apa yang kita nak list kat sini? In the second step, the primary dimension.
Length, time.
Yes, inilah yang ada 7 tu kan. The 7 primary dimension here, the M, L, T, temperature T, I, C, N. Okay, normally the most common primary dimension that we will see is the MLT lah. Okay, the MLT, the most common lah that we will see is about the mass, the length, and the time. Okay, yang lagi 4 ni, temperature, electric current, amount of light, amount of matter ni, it is the primary dimension, but it is not very common. So it's rare to see or to find any parameters that involve these 4 primary dimension. Okay, so normally you will use MLT lah, the primary dimension. Okay, so you need to, in step 2, they ask you list down the primary dimension for each of the n parameters. So we have 5 parameters here. So normally we will do a table. So first for the tau, and then the distance x, and then the rho density, and then the mu viscosity, the dynamic viscosity, and also the V and the velocity, and list the primary dimension for all of these parameters lah. Okay, for the first one is the shear stress. Okay, so what is the primary dimension for shear stress? So they give to you here the unit for shear stress is Newton meter per second. No, Newton minus 2 not per second. Okay, so what is the primary dimension for shear stress? Anyone? The MLT.
M L negatif 1 P square.
M
L negatif 1
L1
P
T
negatif 2.
T negative 2. Okay, well done, that's correct. Can you tell the others how you get this MLT?
Ada dekat slides.
Ada dekat slide. Slide mana?
Ada
Slide
dekat
mana?
atas.
Ha?
Dekat slide yang atas.
Mana atas? Oh ya, ni ke? Ni
Sir.
Okay. Mana ni? Mana shear stress mana? Shear stress.
Kg or stress.
Oh ni. Okay. That's good. But in an examination, you will not given this table lah. This just for the sake of learning. So how you get? So let's say you are in the examination. So you cannot refer this table because you are not provided with this table. So how you can find the primary dimension using the unit? So they give you the unit Newton meter minus 2. So how you can translate this unit into a primary dimension? Anyone? Ada yang ni? Want to try? Never mind, just try. Kita boleh belajar sama-sama. How you can translate this in term of MLT?
Newton tu kita ambil kg
kg
ms squared kan?
Macam mana? Newton ni
Newton kg ms squared.
kg ms squared. Macam mana Newton kg ms squared? So let me ask you, what is Newton? Apa?
Force.
Force kan?
Force.
Okay. Newton is unit for force. Okay, F. So what is force?
ME.
MA.
ms times acceleration.
Okay, so that's why you get this lah. M kg kan? A ms minus 2 no. Okay, ms minus 2 okay, that's apa betul dah. And then how you want to translate this into MLT? So ni mm lah kan, the mass kan, correct? Betul tak?
Betul sir.
And what is A? Acceleration. And
Length.
how we can find A?
Velocity over time.
Velocity over time. Okay. And what is velocity?
L over T.
L over T. Okay, velocity is L over T. So what is primary dimension for A? Is LT minus 2 lah kan? Betul?
Betul sir.
So L T minus 2. So you will have the primary dimension for force Newton is MLT minus 2, and you need to multiply with this meter minus 2. So this is meter ni length lah kan? Meter ni in length kan? So L minus 2. So you will get the final primary dimension for stress for Newton meter minus 2 ni will be M L minus 1 because you have L1 here, and 1 plus minus 2, so it will be minus 1, and T minus 2. So that's how you get the primary dimension for force The shear stress from the unit is M1, okay, M1 L minus 1 T minus 2. So betul lah. Okay, how about the distance X? What's the primary dimension for distance?
L, sir.
L1. We write it as L1. Okay, to get, so after this you will see why I always write the L 1, even though it's not minus 2 ke minus 1, I'll still write it as L1. How about the rho, the density? What is the primary dimension for the rho?
L negative 3.
M1
L
L
negative 3.
minus cube n minus 3 or negative 3. Okay, betul. And mu, the dynamic viscosity. So this is quite tricky lah. It's not very common kan. So what is viscosity? It is apa?
Kg per meter.
Pascal times second kan. Betul tak? Viscosity. And we know Pascal is pressure, and pressure is force over area, and force over area times second. And we know F, dah buat tadi, the MA tu, or the buat M for F. F is mana tadi kan, mana tadi you have done for F. F is M L1 T minus 2 kan. So M1, so F is force, so we have no M1 L1 T minus 2, and over area is L squared lah kan. And S is time, so times time. So we will have this will cancel out, so we will have minus 1. So M1 L minus 1 T minus 1, minus 2 plus 1, so we will have M1 L minus 1 T minus 1 for mu, for dynamic viscosity, because we know the viscosity is Pascal times second kan, pressure times the time. And velocity, this is quite common, is length over time kan. So we will have L1 T minus 1. Okay, so this is the second step lah. So you need to list the primary dimension in terms of M, L and T. Okay, M, L and T for each of these parameters. Okay, step 2. Okay, now step 3. In step 3, you need to set the reduction of J as the number of primary dimension. We want to calculate the K. The K ni number of pi lah. Okay, K ni is number of pi. N ni number of your parameter here. You have come in the first step. N is equal to 5. And J is the number of primary dimension. Okay, so in this question, your primary dimension number is 3 kan. You have M, you have L, and you have T. So 3 primary dimension for the parameters. So your J is 3. Can you follow that? Ada M, L and T. That's why J is 3 lah. Okay, and in the step 3, okay, you want to find the number of pi. Step 3, number of pi and K. Okay, K number of pi lah that you will generate after this. So K equal to N minus J. The N is 5, the J is 3. So you will have 5 minus 3 equal to 2. So you will expect you will generate 2 pi. 2 pi's from this problem. Okay, so that's step number 3. And step number 4. Okay, step number 4 is about choose the repeating parameters or repeating variables. So choose repeating variables, okay, or parameters. Okay, for this question, so they already gave to you in this question. Take X, rho and V as the repeating variables. So step 4 is already given in the problem. So they ask you to take X, rho and V as your repeating variables. So that will left to us. So this is our repeating variable, X, rho and V. So we will have two non-repeating variables, which is the tau and the mu. So this tau and mu is the non-repeating variables. The X, rho and V is your repeating variables. Okay? You can someone just copy and paste the attendance link. For those who just joined, please fill in the attendance link. Okay. So you have three repeating variables given to you, X, rho and V. So the other two, the the tau and the mu is your non-repeating variables. Okay. So that is step 4. And step 5 is to generate your pi lah. Okay, construct the k or the pi. Okay, generate pi. Okay, so we have 2 pi's kan. We have calculate here in step 3, k n minus j. So n is 5 minus 3 is 2. So we will generate 2 pi, pi 1 and pi 2. Okay, so how we can generate this pi, these 2 pi? So let's say for the first one, the pi 1. So we will use the non-repeating variables tau, tau and mu, and the other repeating variables lah. Okay, for the first one, we will take our first non-repeating variables tau and multiply with the repeating variable, which is the x. Okay, x exponential of a1. So that's why I told you why we need to write all this primary dimension with the exponential number. Okay, because we want to find the number of exponential for this repeating variable. Okay, so the x a1, rho b1 and v c1. So this is the first pi that we will generate, and the second pi we will use the other non-repeating variable, which is the mu. Okay, tadi kan tunjuk kan. So this is your non-repeating variable, first one, and this is the second one. Okay, non-repeating variables. So the second pi we use the mu as our non-repeating variable times the repeating variable lah again. So x b1 rho sorry x b1 pula x a2, okay, for the second pi, rho b2 and v, the velocity c2. So our purpose is to find the number of this exponential, this for the a, b and c lah. Okay, so if you notice, so these three is our repeating variable kan. So this is the repeating variable given to you in the question. Okay, and these two, the pi and the tau and the mu is the non-repeating variable. And this pi, okay, pi 1 and pi 2, the dimensionless lah, the dimensionless parameter that we want to generate. Dimensionless parameters that we want to generate for this problem, or the non-dimensional parameters. Okay, so we will solve one by one. Okay, as dimensionless parameters, so we will know that for pi 1, okay, pi 1 equal to tau times the x a1 rho b1 v c1. So this is dimensionless parameters kan. That's why we will have the primary dimension for this pi will be M0, L0, T0 because it's dimensionless kan. So there is no dimension for this pi kan, dimensionless parameter. So the primary dimension, the M and T, the exponential number will 0 lah. Okay, and this will equal to the tau. The tau, we know that the primary dimension for tau is M1, L minus 1, T minus 2. Okay, so we write the primary dimension for tau M1, L minus 1, T minus 2. Okay, times the x is the distance, so this will be the L1. Okay, times the exponential number for A1, and the rho, we know the rho is M1 L minus 3 times B1, and the velocity, we know that velocity is L1 T minus 1 C1. Okay, so we want to, remember, we want to find the number for A, B and C again. Okay, so we solve one by one for M, L and T. For M, so we know M0. Okay, the expression number is 0. So this 0 equal to, so we have 1 M here, so 1 plus, so in here there's no M, so plus 0 lah. And in rho we have 1 M, M1, so M1 times B1, so we will have plus B1. Okay, and in V there's no M, 0. So we will know, we will get B1 will equal to minus 1. B1 equal to minus 1. That's for M. And then we will do for, saya sambung kat sini for L. Okay, so for L, 0 again, 0 equal to, so we have 1 L here with the power of minus 1, so minus 1, and we have another L in X, L1 times A1, so we will have plus A1, and we have L in rho, L minus 3 times B1, so we will have minus 3 B1, and we have another L in velocity, L1 times C1, so we will have plus C1. Okay, and because we have two unknown, A and B, A and C, we know B is minus 1, so we can write as 0 minus 1 plus A1. So B1 is minus 1 times minus 3, so will be plus 3 plus C1. So we still have two unknown. So we start for the T first. For T, again do the same. For T, 0 equal to T minus 2. So we have minus 2. There's no T in X, there's no T in rho, and we have 1 T in velocity, minus 1 times C1. So this will be minus C1. So we will get C1 equal to minus 2. Okay, so we will use this value in the L equation so that we will get A1 will equal to 1 minus 3 minus C1, and C1 is minus 2, so plus 2. So this will give to us 1 minus 3 is minus 2, plus 2 is 0 lah. Okay, so we will have A is 0. So to solve for this, the pi 1, okay, we know pi 1 will equal to the tau times the x A1, and we know A1 is 0, so power of 0, and rho B1 is minus 1, and V C1, and we know C1 is minus 2. Okay, so this will solve our first pi, and we can write our pi 1 will equal to tau over x naught, kosong lah, tak ada apa, and P minus 1, rho minus 1, so we over rho, and V minus 2 over V squared. Okay, so this will be our first pi. Okay, can you follow until here?
Yes, sir.
Boleh Okay. And we do the same for our second pi. We have 2 pi kan. So this one dah settle, pi 1 dah settle. We need to do the same for pi 2. So pi 2, saya tambah dulu slide. Tak ada ruang dah. Sekejap Okay, so pi 2, so we know pi 2 is equal to mu times the x a1 rho a2 rho b2 and v c2. Okay, and again pi 2 will be also dimensionless parameters, so this will be m0 l0 t0 lah, because this is dimensionless kan. And mu, we know mu is the primary dimension for mu is m1 l minus 1 t minus 1. So we write the primary dimension for mu m1 l minus 1 t minus 1, and x is l1 times a2, and rho, we know rho m1 l minus 3 b2, and v is l1 t minus 1 c2. Okay, so do the same step for pi 2 to solve the pi 2. Okay, for m, so 0 equal to m1, so 1, plus there's no m at x, plus 1m in rho times b2, so will be plus b2, and there's no m here in v, so b2 will equal to minus 1. Okay, and then we do the same for L. Okay, L0 equal to 1L here, minus 1, minus 1, and plus there's 1L in X times A2, so will be plus A2, and we have another L in rho, so minus 3 times B2, so this is minus 3 B2, and we have 1L in velocity, 1 times C2, so this will be plus C2. Okay, sorry, I need to keep doing this. Okay, come back to our slide. Okay, that's for L, and then we still have 2 unknown, A and C, so we'll leave it here first, and we do for T. So for T, 0 equal to minus 1, and there's no T here, there's no T here, and we have 1 T in velocity, minus 1 times C2, so this will be minus C2. So we will know C2 equal to minus 1. Okay, using the value for B2 and C2, we will get A2 lah. So 0 will equal to minus 1 plus A2 minus 3 B2, and B2 is minus 1, so this will be plus 3 lah, plus 3, and plus C2 is minus 1, so this will be minus 1. So we will get A2 equal to 1 minus 3 plus 1. So this will equal to 1 minus 3 is minus 2, plus 1 is minus 1. Okay, so we will have our pi 2. Pi 2 will equal to mu times x a2, and a2 is minus 1, rho b2, and b2 is minus 1 as well, and v c2 pun minus 1 juga, so v minus 1. So we can write our pi 2, then ada another dimensionless parameters equal to mu over x plus minus 1, rho and v. So this will be our second pi, mu over x, rho and v. So this is the step 5. Okay, the last step, okay, the step 6 is to write your pi lah, your pi function. Remember, the pi function is pi 1 equal to f times pi 2 kan, or if you have more pi, so it will be pi 3, pi 4, and so on and so forth lah. Okay, in this equation, in this problem, you only have 2 pi kan, pi 1 and pi 2. So your pi 1 is here, tau over rho v squared. So you write again your pi 1 tau over rho v squared equal to the function of the pi 2, and your pi 2 is mu over x times rho times v. So this will be your final your function, your pi function, and you can write the equation problem tu nak ni kan, determine an expression of wall shear stress. Sorry, okay, they ask you to determine an expression of wall shear stress tau. Okay, so we have to write our final function as tau equal to something. Okay, but that's the question kan, write an expression of tau. So tau will equal to, we bring all this term to the other side. Okay, rho v squared. Okay, rho v squared function mu over x rho v. So this will be your final answer, your expression for shear stress. Okay, any question, anything that you don't understand? Ada yang
Sir,
ha,
nak tanya tentang
Silakan.
step 2 atau step 3.
step 2 and step 3. Okay, here. Okay,
Sekejap.
kat mana yang nak tanya?
Saya cuba next page.
Next page. Step 4, step 5.
Ini macam mana nak bezakan dimensionless parameter, bukan. Macam mana nak bezakan repeating variable dengan non-repeating?
Okay, repeating variable is already given to you in the question. Take x, rho and v as the repeating variables.
Oh, dia dah bagi
Dia dah bagi dah. But you will find maybe there is a question that they don't give you that repeating variables. So that's why in step 4 I will discuss after this how we can choose these repeating parameters or repeating variables. But in this question they already given to you the x, rho and v as your repeating variables. So x, rho and v your repeating variables. So you will have so this is repeating variable, x, rho and v your repeating variables. So the other two, the tau and your mu, this will be your non-repeating variables lah. Boleh?
Oh, okay. Boleh sir. Thank you sir.
So I will show to you after this how we can choose in step 4, how we can choose the repeating parameters if they did not give to you in the question. Okay, we will discuss after this. Okay, any other question from anyone else?
Sir,
Ah,
for the last step yang kan macam
step
dia
6.
minta yang pi 1 equal to f lepas tu pi 2 tu kan, kalau ada more yang macam ada pi 2, pi 3 tu macam mana saya nak buat?
Tulis saya balik, tulis saya pi 3 awak sini, sambung tulis.
Tulis je tak payah apa-apa.
Awak tulislah pi 3 apa, because in step 3, okay, we have determined our number of pi in step 3 kan. So we will calculate how many pi's that we will generate after this in this method lah. Okay, and in this question when you get your n is 5, j is 3, so your pi is only 2. So let's say you have the n number is 6, let's say you have another one here, t ke apa kan. So your n will be 6. So when you go in step 3, you will get your pi number is 3 lah kan, 6 minus 3. will be 3 kan. So you will have another pi 3, okay, and you will generate that pi, and when you in your last step you just write again what your pi 1, pi 2 and pi 3 lah if you have 3 pi. Did that answer your question?
Yes, sir. Thank
Okay.
you, sir.
Alright. Anything else? So in this method of repeating variables, the most important step yang paling penting ialah dekat step 2 ni. Step 2 ni yang akan menentukan your next step betul. If you did not get this primary dimension correctly, you will find a problem lah. Let's say you write your primary dimension for tau ni ml l minus 2 ke apa-apa lah yang salah. When you do this, it will affect your calculation lah for your exponential ni kan. Kan I write here kan. So you will write ml apa again, and if you write it wrongly in the step 2, you will find the exponential number incorrect lah, salah kan. So you will get the wrong answer lah for your pi. So that is the most crucial step in step 2, and you need to find do it calmly, invest more time in step 2, find the right primary dimension for each of these parameter, for tau, for x, for rho. Do it slowly, don't rush. Confirm dulu, pastikan betul, ensure that primary dimension is betul, then you go to the next step. Okay? Boleh? Any other question? Ada soalan lain? Tak ada Okay. Okay. So the primary dimension tu kat sini lah from this table. This is the common common quantity, velocity, acceleration, force, and you can learn from here lah what is the primary dimension for each of this quantity. But remember, this table is not given to you in the exam or in the test, so you cannot refer this table kan. So that's why you need to know lah how you can find the primary dimension for each of these parameters lah. Okay. Alright. So that is how you use this method to generate the dimensionless parameters. So this example is quite easy because it's given to you, the repeating variables x, rho and v. How about if they did not give to you this repeating variables? For example, this question. In this example, some aeronautical engineers are designing an airplane and wish to predict the lift produced by their new wing design shown in the figure given. The parameters involved to determine the force lift Fl on a wing are the chord length at an angle of attack alpha in a flow of free stream speed velocity with density rho, viscosity mu, and speed of sound c. So develop a non-dimensional relationship between the force lift Fl and the other parameters in the problem. If you look in this example, so they did not give you the repeating variables kan? Tak ada kan? They did not give to you. So in this question, okay, so we go again step by step. Okay, the first step is the list the parameters kan? Step 1 list all the parameters and calculate the number of n. Okay. So who can list the parameters given in this example? So they said the parameters involved to determine the force lift Fl. Okay, I help you the first hint, the Fl. Okay, what's next? Siapa boleh tulis? Anyone want to try? Don't worry.
Length sih.
Huh?
Length.
length. Okay, you just write lah apa FL. Okay, you say kan FL involve determine the force depend on this kan L everything kan. So the force lift is a function of, okay, you said is L, okay, right? The LC, the apa the code length, okay, that's the first one. Lagi
Velocity.
okay, velocity. Lagi
Density.
density, okay. Lagi
Viscosity.
sini dah, ni dah, and ni dah apa viscosity, okay, mu, okay. Lagi
To speed of sound.
sound, okay. Okay, ada lagi tak?
Tak ada sir.
You miss this one? Angle of attack and apa? Angle of attack as well. So that's all lah the parameters given in the problem. Kalau you say here to the parameters involved to determine the force lift, the FL on the wing are, okay, the chord length LC at an angle of attack, okay, alpha, in a flow of free stream speed velocity with density rho, viscosity mu, and speed of sound c. Okay, what is the number of n here? The number of parameters.
Ada 7 sir.
7. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so you have 7 parameters lah altogether, including the force lift kan, the one that they want to determine. Okay, so that's settled for the first step. So the second step is to list down the primary dimension kan, the primary dimension for all of these parameters kan. Okay, so you do again the table. So the force F, the lift force, and then the length, and then the velocity, and then the rho, and then the mu, and then the speed of sound c, and also the angle of attack alpha. Okay, what is the primary dimension for force? We have discussed earlier. Force is equal to ma. So ma, so m is mass, and m1, the a is acceleration, and we know acceleration is L1 t minus 2 kan. Betul?
Betul sir.
Okay, so that is the first primary dimension. Sorry. Okay, and then the length senang lah, L kan, L1. And velocity again quite common, L1 t minus 1 kan. And the rho, mass over volume. Okay, so m1, volume is L cube kan, so L minus 3. Okay, and the mu tadi kita dah buat dah mu kan, m Pascal times second kan. So again, I also did not really remember tadi.
M1 L negative 1 T negative 1.
Betul. Okay, so M1 L negative 1 T negative 1. Betul?
Betul sir.
Okay, the C, the speed of sound. Speed of sound ni velocity jugalah kan, sama kan. Speed of sound, speed lah. Okay, so will be L1 T minus 1. And angle of attack, what is the angle of attack? The primary dimension for angle of attack.
Tak tahu sir.
Angle of attack ni apa? Kita dah discuss tadi earlier. It is a non-dimensional variable kan. So there is no dimension for angle kan. Okay, so there is no primary dimension for angle. Okay, so it's just a number lah. Okay, just a number, and there's no dimension. There's just number of angle, 60 ke apa ke. So there's no primary dimension for angle of attack. Okay, so this is your second step. So make sure this second step again, as I advise to you, make sure all the primary dimension for these parameters are correct. Okay, double check. FMA, so M1 N1 T minus 2, the length is L1, the velocity length over time kan, distance over time, so L1 T minus 1, the rho mass over volume, so M1 L minus 3, the mu Pascal times second, so M1 L minus 1 T minus 1, and the speed of sound is the speed lah, L1 T minus 1. Okay, if you are confident enough and you already make sure the second step is correct, then move to the third step. Okay, the third step is soalan.
Yang angle tu tak ada apa-apa.
Tak payahlah sebab there is no dimension. Angle ni tak ada dimension kan? So just a number lah, 1. Or you can just write nothing lah. Tak ada pun ML or T.
Okay, baik sir.
Okay. Angle of attack or what apa yang constant lah, yang constant yang tak ada unit. Okay, and the step 3 is calculate the pi kan, calculate the number of k, calculate k, and k is k n minus j. Okay, and your n, so you already obtain n is 7. Okay, 7 minus j. So tell me what is j, what's the value for j?
3.
So you have M, L and T lah. So you have 3 primary dimension in either one of these parameter lah. Okay, so you have M, L, T. So the number of primary dimension is 3, or J is 3 lah. Okay, so 7 minus 3 is 4. So you will generate 4 pi, 4 pi in this problem. Because there are a lot of parameters, 7. Okay, so that's why you will generate a lot of pi lah. So in this case you have 4 pi. So you will generate pi 1, pi 2, pi 3 and pi 4. Macam soalan tadi saya tanya tu. So you will have your function after this, pi 1 equal to f pi 2, pi 3 and pi 4. Okay. So in step 4, ini yang penting ni, because in this question they did not give to you the repeating variables. How you can choose which one that you want to use as your repeating variables. So this is the step 4 that we will discuss here. Okay, they will provide you the guidance, the guidelines for choosing the repeating variables. Okay, before that, normally, not always, normally. Okay, normally in a question, in your subject, this subject, normally the repeating variable is given in the question. Macam ni lah contoh yang saya tunjuk tadi tu. In this one. So this is from past paper. So normally they give to you the repeating variable x, rho and v. Okay, but not always. That's why we still need to know how we can use this guideline to choose the right repeating variables. Okay, so that means you still need to know how to choose the repeating variables. Okay, so you have a lot of parameters here. Ni kan ada L, V, rho, mu, C and A. So how we want to choose the repeating variables? Okay, we go one by one from the guideline. Okay, so from the guideline, the first guideline is never pick the dependent variable. The dependent variable, never pick the dependent variable. So I ask you here, so what is the dependent variable in this problem? Apa yang dependent, which one is the dependent variable? F ni kan, FL ni kan. So this is dependent variable kan, because this depend on L, V, rho. Okay, so this is our dependent variable, and in the guideline said you never pick the dependent variable, so we cannot choose this one. Okay, so we cancel out that. Okay, so we leave to us other 6 parameters to choose. Okay, Alright. So the next guideline, okay, it says the chosen repeating parameters must not by themselves be able to form a dimensionless group. Okay, so you have other 6 parameters kat sini. So these 6 parameters, either lah 1 or 2 or 3, you cannot choose the parameters that can form themselves a dimensionless group. Can you for example, just give you an example here. Okay, let's say there are t time, the w naught is the vertical speed, and this guideline is referred to this problem lah actually. Okay, the w naught is initial speed and the z naught is the distance. So these 3 they can form by themselves another dimensionless parameters. If you multiply t with speed over z naught, this will be a dimensionless parameter. There will be a no down dimension. So you cannot pick t, w naught and z naught all together because they can form a dimensionless parameter. Okay, so that's the second guideline. Alright, and the third guideline is the chosen repeating parameters must represent all the primary dimension. So in this example, so we have primary dimension, we have m, l and t kan. So we cannot choose the repeating variable only, for example, l, v and c, because there is no m inside kan. We need to choose repeating variables which has all the primary dimension, at least ada m, l and t lah. Okay, so we need to choose that. So this comprise every primary dimension that we use. Okay, so that's the third guideline kan. And the fourth guideline, never pick parameters that are already dimensionless. Okay, in this example, what is the parameters that already dimensionless?
Angle of attack.
Angle of attack. So we cannot choose this as our repeating variable because it is already dimensionless. Okay, so we leave to us only 5 lah. Okay, L, V, rho, mu and C. Okay, so we need to choose 3 kan, 3 repeating variables. We need to choose 3 repeating variables. Okay, because we know our J is 3. Okay, so this also lah repeating number of repeating variable will according from this number of J. Okay, so we need to choose 3. Okay, from these 5 we have already cancelled 2. Okay, so refer again the next guideline. Never pick 2 parameters with the same dimensions or with dimensions that differ by only an exponent. Okay, don't pick the same dimension. Okay, for example this one V and C is the same kan. V and C ni the same dimension L1 T minus 1. So we cannot choose both of them. We can only choose one je, either V or C. Okay, so we can cancel out one lah. Okay, so we cancel out C. Okay, for my example I cancel out C because it's this same dimension with V kan. Okay, the L1 T minus 1 ini pun sama juga. Or you have the dimension tu only differ by the exponent, and let's say the velocity and acceleration, and velocity is L1 T minus 1 kan, and acceleration is L1 T minus 2. Okay, the difference is only on the exponential, so you cannot choose both of them. So either you choose V or either you choose A, and the acceleration. Okay, so we cancel out A here, so we only have 4 left, L, V, rho and mu. Okay, so we want to choose 3 kan. Alright, so defer the next guideline, which is it say whenever possible choose dimensional constants over dimensional variables, so that only one pi contains the dimensional variable. So this example they give to you, they cannot choose t because if you choose t in this example this ball jatuh, so they have z naught, the initial elevation, the height L, and z and another z is L also. and you have G, and you have speed and acceleration. And they cannot choose T, because if they choose T as the repeating variable, it will appear in other pi. Okay, so this is quite tricky lah for step 6. But in our example, so we don't have that. The next guideline is pick common parameters. Choose yang parameter yang common, macam apa, length, time, density, velocity. Okay, so in our problem, so we have the length, the velocity, the rho, and the mu. So what do you think the most yang paling tak common antara empat ni? Apa yang paling tak common? Can anyone suggest?
Viscosity.
Viscosity kan, it's not very common. Okay, it's not like length, it's not like velocity. It's rare lah. Viscosity tu parameter yang agak uncommon kan. So we ignore this one. We can cancel out the mu. Okay, because it's not very common compared to L, V, and rho kan. We can cancel out the mu. So it's only left to us only three kan. The length, the velocity, and the rho. So it's it's already answer our question lah. How we can choose the repeating variable after we cancel out everything? The left to us only the length, the velocity, and the rho. So that's how you use this guideline, okay, to choose the repeating variables. So you need to understand this, okay. Even though I said that normally in the question give already the repeating variable, but let's say this year they don't provide to you this repeating variable, so you need to know how you can use this guideline to choose the repeating variable. So now we have done our step 4. So we have choose the length and the velocity and the rho as our repeating variable. So we have 3 repeating variables. Okay, L, V, and rho, and we have 4 non-repeating. We have FL 1, the mu 2, the C 3, and the alpha 4. Okay, so we have 4 non-repeating variables and 3 repeating variables, because we want to generate 4 pi kan. So that's why we have 4 non-repeating variables. Okay, step number 5. Step number 5, we have to generate the pi. Generate pi lah. Okay, so pi 1, we will have, okay, use our first non-repeating variable, the FL. So FL times the repeating variable is the L, V, and rho. So L, C, A1, V, B1, and rho C1. So this is our first pi, and our second pi will be the next non-repeating variable is the mu. Okay, the mu times the LCA2, VB2, and rho C2. And the third pi will be our next non-repeating variable is the C. Okay, the speed of sound. Okay, LC A3, VB3, the rho C3. And the last pi, our fourth pi, will be the angle of attack again, alpha times the LC A4, VB4, rho C4. Okay, so we need to do one by one, macam tadi, solve for the first pi, the second pi, the third pi, the fourth pi, to find the number of the exponential lah, A1, B1, C1, A2, B2, C2. Then the last step, the sixth step, we can write our pi equation kan. The pi 1 equal to function of pi 2, pi 3, pi 4 lah. Okay, so maybe I show you 1 or 2 pi, and you can do the rest lah. So it's only half past 1. Okay, pi 1, okay, FL times the LC A1, V B1, row C1 So again, this one is the dimensionless kan. The pi ni semua dimensionless pi 1, pi 2, pi 3, pi 4 ni semua dimensionless parameters. Okay, so that's why each of them is M0, L0, T0 lah because dimensionless Okay, the FL, so we have the force, primary dimension for force is M1, L1, T minus 2. So M1, L1, T minus 2. Okay, for force times the L, so we have L1 minus times A1, V, L1, T minus 1 times B1, and rho M1, L minus 3 times C1 So that's why I said to you, always write the number of the exponential for each of these primary dimension M1, if it's M1 then write M1. So you will write, you will use this number to write your equation to find the number of the exponential. Okay, so then you solve for M. So M0 equal to, you have 1M here, so 1 plus, so there's no M here, and there's no M here, and you have 1M in the row, so M1 times C1, so will be plus C1. So C1 will equal to minus 1 lah. Okay, so and then for L, okay, solve for L, so 0 equal to L1, satu sini L, plus A1, 1 times A1 plus A1, plus L1 times B1, so plus B1, plus minus 3 times C1, so minus 3C1. Okay, and you have two unknown, A and B, so we cannot solve this one first. Solve for T, for T, okay, for T first, so 0 equal to, we have minus 2 plus ada T, plus 1T here, minus 1 times B1, so this will be minus B1, and here is no T, so we have B1 will equal to minus 2. Okay, and then we can solve for A, so 0 equal to 1 plus A1 plus B1, B1 is equal to minus 2, so minus 2, minus 3 C1, C1 is minus 1, so minus times minus is plus, so plus 3 lah. Okay, and A1 will equal to minus 1 plus 2 minus 3, so this will be minus 1 plus 2 is minus 1, minus 1 minus 3 is minus 4. Okay, and minus 1 plus 2, sorry, minus 1 plus 2 is 1, oh sorry salah, eraser. Okay, minus 1 plus 2 is 1, 1 minus 3 is minus 2 lah, not minus 4. Okay, so you have to be careful lah when you calculate. It's simple but need to be careful. Okay, so we know the exponential number for A1, for B1 and C1, then we can write our pi 1 as FL times LC, A1 is minus 2, and V, B1 is minus 2, and rho C1 is minus 1. Or we can write as pi 1 FL over, and because everything is minus, so LC squared V squared rho. So this is your first pi. Okay, so you have another 3 pi to solve. Okay, when you find your pi 2 upper, and pi 3 upper, and pi 4 upper, then you can do the last step, the step 6. Write your final pi equation as pi 1 equal to F times pi 2, pi 3, and pi 4. Okay, I'm not sure to you how to do this 3 pi 2, pi 3, pi 4. I leave it to you to do. Okay, solve this pi 2, pi 3, and pi 4, and you will get your final answer lah for step 6. Alright, any question? Ada soalan? Hello?
Ada sir, ada.
Okay. Can you do the rest? I leave it to you. Pi 2 to find pi 2, pi 3 and pi 4.
Boleh.
Okay? So that's your homework lah for today. You can do it at your own time or your own pace. Okay? But I just ask if you not clear anything in this step, in this method of repeating variables and pi Buckingham pi theorem.
Sir nak tanya yang
Di mana?
kenapa nilai J dia 3 dekat soalan ni?
J dia 3. Ni, soalan ni.
Macam mana boleh dapat 3?
Again, J is the number of primary dimension kan?
Oh, okay.
Okay. So that's how you get 3 lah. M, L and 3. Okay. Any other question?
Tak ada sir.
Tak ada. Okay. That's fine. Okay, I hope you understand how you can use this method, okay, the method of repeating variables to generate the dimensionless parameters. So my advice again, invest more time in step 2, the primary. If you see, I give to you another example tomorrow to do tomorrow. Okay, we do it tomorrow again together. And in step 2 ni we very careful. Make sure the primary dimension is correct lah for all of these parameters. Otherwise, you will find a problem lah to solve this problem. Alright. If there's no more question, I think that's all for today. And thank you for your attendance, and we will meet again tomorrow at the same time. And we will do a few other tutorial lah. I will show a few more tutorial, and then we can wrap up lah for chapter 5. Or you have any question, you can ask tomorrow as well. Okay. Again, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you.